Assalamualaikum and salam sejahtera. My name is Noshami binti Abdulatif. I'm gonna to present about DEXI, which is parallel operation of synchronous generator. Firstly, I will present about parallel to three-phase synchronous generator under no load condition. Firstly, we construct this circuit and then we set the parameter of induction motor and synchronous motor. The frequency for generator 1 is 51.5 and generator 2 is 51. For simulation control, we set the total time is 3 and the VF for generator 1 is 105 and generator 2 is also set. For the resistor will be set 2.35. both of the generator 1 and generator 2, for the resistor for generator 1 and generator 2. Finally, we simulate this circuit and the result will be in the waveform. The value of RMS for this circuit are not the same because it is in the no load condition. For the question 3, to design the parallel connection of three-phase synchronous generator, they have the condition. The RMS value for the line must be equal or the same value. The two generators must be in the same sequence, and the two generators must be in the same phase, and lastly, the frequency of the new generator must be higher than the frequency of the running system. To design this parallel generator, the bi-directional switches are added into the circuit. Then, lastly, the value of RMS will be the same or equal by adjusting the VF at G1 and the VF at G2 is remain constant. For the same sequence, we just set the value of parameter at generator 1 and generator 2 the same value. Secondly, when it operates in the phase condition, generator 1 and generator 2 must have the same phase. Finally, at 0.1 second, both of the generator are connected in parallel operation, which produce in phase waveform. The frequency of generator 1 must be slightly higher than the frequency of generator 2. Lastly, at square wave source, the frequency is set to 0.33 and duty cycle will be set 0.24. Since the suitable time to two generators to connect in parallel connection is 0.71 second. From this circuit, we can conclude that when the time taken of 0.9 to near to 1 second, both generators not in parallel connection since the waveform is not in phase. When time taken 0.7 second. Both are the generator operating in parallel. Generator G1 and generator G2 are the same. The RMS value for both generators are the same, which is 433.9. That's all from me. Thank you.
Assalamualaikum and hi, my name is Aini Sofia binti Abdul Muttalib. Today I would like to present my part for question 1 and question 2 for 5.2 behavior of synchronous generator operated in parallel under load condition. For the 5.2 we set the resistor is 30 ohm and for the inductance we set 230 millihenry. For the both generator we set 51.0 Hz. For the question 1, it asks the waveform of the line voltage of two three-phase synchronous generator for the time 1.2 to 1.5 seconds. After that, we simulate the circuit. So this is the waveform of the question 1. It asks for 1.2 seconds until 1.5 seconds. For the RMS value of the line voltage for generator 1 is 4.187 and for the line voltage for generator 2 is 4.271. It is slightly different from for line voltage generator 1 and for the line voltage generator 2. That's all. For the question 2, the question asks to design a parallel connection for the line voltage waveform of two three-phase synchronous generator. They have several conditions to design the parallel connection. Firstly, should have equal of the RMS line voltage. Second, synchronous generator SG1 and SG2 required to ensure the resulting of output is in phase, has same frequency and voltage. Third, three-phase must be matched to prevent excessive mechanical and electrical stress to avoid power surge. Lastly, waveform of the line voltage should be same such as they rise and fall together. Should be no different angle potential difference between the phase should be zero. Okay, for the step is first synchronous generator 2 synchronous generator 2 and synchronous generator 2 must run on different moment. The synchronous generator 2 runs for a duration of 0.1 second after the initial generator operating time SG1. Add on time to make it happen, which is consists of bidirectional three-phase switch, NOT gate, source of square wave, voltage, and on-off control. Second, after that, the pulse generator control the three-phase bidirectional switch. The pulse generator control the three-phase bidirectional switch. According for a time of 0.1 second, change the square wave voltage source. The frequency of the voltage of the square wave source is set to 0.2 second and the duty cycle is set to 0.02 second. For the time step, the simulation control parameter is set to 0.00005 second and the total time is set to 5 seconds. 51 Hz is the frequency of both generators. Run the simulation and the line voltage of SG1 and SG2 are recorded. So we can conclude that the parallel operation exists at 1.36 seconds, but the value of the line voltage between both generators is not the same. Since the waveform is in the phase, two generators work together. Other than that, bidirectional switches are connected to the circuit to design the parallel connection. VF of the VF is 0.3 volt is set. Lastly, add another control time connecting each other to a synchronous generator SG1 and SG2. Since the parallel operation occurs at 0.36 seconds, the square wave voltage source frequency is set at 0.2 seconds and the new duty cycle is at 0.272 seconds. At 1.36 seconds, both of them in parallel operation generator that generate an increased waveform are connected. That's all from me. Thank you.
Hi, Assalamualaikum. I'm Hayuni. For my part, I will explain for part 2 for parallel condition. And then for my part, I will explain for question 3 and question 4. For question 3, the question is to show and analyze the line current waveform of both synchronous generators and load before and after paralleling condition for the time 1 to 2 seconds. And then this is the simulation waveform that we get. From the waveform, we can see that the waveform between them is slightly different. Okay, for load current waveform, the result shows there is no difference and the waveform are in the same condition from 1 second to 2 seconds since it is connected in series with the generator 1. Okay, then for synchronous generator, which is SG1, the result shows when the time reach 1.36 seconds, the line current and waveform are changed a little bit. But after 1.36 seconds, the waveform are start normally. Are start to flow normally after this waveform. Okay, for the line waveform for a synchronous generator SG2, the waveform shows that there is no current flow until the time reach 1.36 seconds. But after 1.36 seconds, the current start to flow, and after 1.605 seconds, the line current is start to flow normally. Okay. In here, after this waveform, the current will start to flow normally. Okay, for question 4, the question need us to showing the current and voltage waveform of both synchronous generator and load after paralleling condition for the time of 4.5 to 5 seconds. And then we need to measure and analyze the real power. Okay, this is the waveform that we get for question 4. Okay, for the these three waveform, we can see that the waveform is almost same, but the difference is between the values after we measure the waveform for the real power values. In this waveform, we need to set the time 4.5 seconds to 5 seconds in a paralleling condition. Then we will get the value of real power. Okay. So based on the result that we get, the highest real power are from line voltage and current from generator 1, SG1, which is 811.295 watt. And then the second highest values from line voltage and current generator 2, which is SG2, which is 193.1 watt. Okay, lastly, the lowest real power are from line voltage and current load, which is 100.4 watt after the paralleling condition. Okay, that's all from me. Thank you.